Chapter 2 of the Lippmann-Rasmussen, the test we took, number C. Okay, I'm going to go through and do this one for you in case you had some questions. So I want to graph the miles driven as the independent variable. So it's got to go across the bottom. I control how many miles I drive. I can't control how many gallons of gas left in the tank directly anyway. So let's see here. I'll move up here so you can see what I'm doing. Horizontal axis for the independent variable. And I'm going to put 0 here, and I got to get up to 300. So I'm going to go 0, 20, 40, 60, 80, 100, 20, 40, 60, 80, 200, 20, 40, 60, 80, 300, and that's miles is the units, and that's the miles driven, or the distance driven in my car. Okay, now I'm going to make the vertical axis. It'll be easier if I turn it this way. I'm going to go through 0, 0, and this has to get up to 9, so I think I can do that if I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's gallons of the units, and this is gas used. Okay, so 1, you're supposed to draw the graph, including label the axes and showing the units. So I've got the units marked in numbers, I've got the labeled what units they are, and this. Now I'm going to do my plotting of the points. 59, 9, 20, 40, 50. 80, 8.5. 8.5, 20, 40, 60, 80. 100 at 8, 8, 20, 40, 60, 80, 100. Oh, get it up where you can see it, sorry. And 120 on 7.5, 7.5. 20, 40, 60, 80, 100, 120. 7, I got to do at 140. That's 120, 140. And 6 on 200. 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. And 300 on 4. So 4, 300, I think is right there. Okay, I'm going to try to draw the best line I can with the kind of tools that you might have had when you had the test. Maybe just another pencil. Okay, I got a point above, point slightly above, on, a couple below. That might be a little bit high, but close enough for this. And so now I got to pick a couple of points. This looks like a nice point. It's halfway across, so that's 20, 30. 30 miles driven. Amount of gas in the tank is 9.5. And another point, this one looks pretty good. This one looks pretty good. This one was 300 miles driven and 4 gallons in the tank. So my slope, it went from 9.5 down to 4. That's 5.5 gallons used to cover down, so it's negative. to go from 30 to 300, which is 270 miles. Now you won't get exactly the same as I got here, but you should get something in the ballpark. And so if I change this to decimal, I'll know whether you're in the ballpark with me if I do yours in decimal. So 5.5 divided by 270 is 0.02. Negative 0.02. And this would be gallons per mile, meaning I'm using 0.02 of a gallon per every mile, or using 5.5 gallons to go 270 miles. Okay? So, using 200ths, 1/50th, or 200ths, using 0.02 gallons to drive 1 mile. Okay? And the y-intercept. Well, it said I filled up at the service station, and this is 10, so this is like 10.2. And that would be 10.2 gallons for no miles driven. That's the y-intercept, and it's the size of the gas tank. So it's a 10.2 gallon gas tank. Okay, that's number one. Now, number two, I need to do on Desmos. So I'm going to pause this one here, and I'll have to make another video doing a screenshot. Number two. And so I have to pull down a table and enter my data. And so the data, you won't be able to see the paper now, so, but it's 50, 80, 100, 120, 140, 200, and 300. And the gallons left in the tank were 9, 8.5, 8, 7.5, 7, 6, and 4. And we should be able to see this on the graph if we get in the right place. The miles driven is really pushed in, so I'm going to go to the wrench and say I want X to go from, that's fine, to 400. And there's the data. And so it's graphed, and the first thing I asked for on this problem was use technology to turn the line to best fits. So to do this, we have to use Y1 and X1, and we want Y1. We want it to figure out what it equals, so we're not going to do equals. We're going to do tilde up in the upper right-hand corner, or if you use it on here, the tilde is on the ABC right there. Anyway, we need a slope times x1 plus a y-intercept, and I'll just put a b, and now it's picking a line. This line is similar to the one I wrote. If you go back to the problem we did, I had negative 0.02, same as this does. This has a y-intercept of 9.9, so that's predicting that my gas tank holds 9.9 gallons. Actually, close to 10, whereas my line, when I drew it by hand, said 10. So, and the correlation coefficients is, you can use either one of these. Most commonly used one is the R squared, and it's 0.99, which means this line pretty much gets really close to all the data. And you can see it. It looks like it hits those 1, 2, 3, 4 of the dots. 2 of them are below and 1 is above. That's a pretty good fit when they're not very far away. Okay, I'm going to stop this one, and then I'm going to go back and do problem 4. So, in this, okay, question 4, we're supposed to decide whether this is increasing or decreasing. So it's y equals, this doesn't have the x, so this must be the y-intercept. This must be the slope, and it's plus 5, so it's going up. This one has no x over here. It's 3 minus 5, which is 2, so it's not times an x, so it's a constant. And this one has got a negative 0.5 times the x, and a negative means it's decreasing. And now if I got to find the equation between 2 points, I could use Desmos, but the y is increasing by 3. Goes from 3 to 6. That's increasing by 3. The x goes from 1 to minus 3. That's going down by 4. So the slope is negative 3/4 x, and the y. And we have to figure out what to add to this so that it matches my points. Now, if I put 1 in here, I get negative 3/4 plus something is supposed to equal, if I put in 1, I'm supposed to get 3. What do I add to negative 3/4 to get 3? Well, I'd have to add 3/4 to get to 0, and then 3. So I'm going to have to add 3 and 3/4. So there's my equation. Now, you may have written it, y equals negative 0.75 3/4 plus, let's see, that's plus 3.75. Okay, 8. So if I make a little table here, it says 1970, the year, is supposed to be year 0, t equals 0, and the population was 2,500. And then in 1995, which is 25 years past 0, the population was 2,800. Okay, so now if we're going to make a model for this, it'll have to have the numbers in it, and it'll be the population as a function of time, or y if you want, but it'll be the slope, which this went up 300 in 25 years, times the number of years, which was t, plus the beginning population. Well, that's when the y-intercept, when t is 0, it was 2,500. Now, 300 divided by 25 is 12. So what this means is it was going up 12 people per year. But anyway, we're supposed to figure out what it is for 2005, which is 35 years later. So I got to put 35 in for t, take it times 12. So if I take 35 times 12, I get 420 people were added to the 2,500. So the population at 35 is 420 plus 2,500, which is 2920. That would be the population. That's what it predicts for 2025. Now, the model may be right, might be wrong, but that's what the model predicts. It may not be what actually happens. Okay, now I'm going to go back to Desmos to do the last one. Okay. So model the data given. Didn't give you any kind of scenario for it, so it's just a bunch of data. So I can get rid of this stuff. Start a new table, and the x values were 1, negative 0.5, 2, 4, negative 1, negative 1.5, and 0 and 10. And the y values were 2.3, 3.7, 2, 1.7, 5, 9, 3, 1.3. And most of these are between 0 and 10, so I'm going to go to my wrench and make this go to 10 and make the y go from 0 to 10. That's close enough. And I get this curve. And of the ones that we talked about, I know some of you are using technology to come up with models, but I expected you to use the models that we talked about. And the models we talked about were, y equals x, y equals x, or we talked about y equals x squared. That doesn't look like it. We talked about y equals the square root of x. That doesn't look like it. And we talked about 1 divided by x. And that, get this out of the way, that could be it if we moved it up and over. Now, some of you did exponential. We didn't talk about exponential. I don't expect you to do exponential. So now, how do we get this Desmos to allow it to mess around with this curve? So to do that, we go back to here and say, we want it to look at the y1 and make something with a now we got to go to the tilde. And the equation was 1 divided by x, but we want it to be able to be flexible. Now, the x is in the denominator, so if we want to move the graph sideways or stretch it sideways, they would have to come around the x. So I'm going to put an ax plus b, and that allows it to move the graph sideways. Oh, this has to be x from here, which is x1. So now it's getting fairly close, but I want it to be able to do move it up and down and to stretch it up and down. So that happens to the whole thing. So I need to put a times something here, like maybe c, and then add something at the end, d, and now it gets really close to the data. In fact, it says that the r is squared is 0.9999. That's a really good fit for the data. So when you write this on the paper, and I'll have to make another video, well, I won't have to, I'll just tell you, I want you to write this equation, not with the letters in it, but with the numbers in it. So the model would be y equals C, which was what, 14, parenthesis 1 divided by A was 3.46, X, and the B was 6.94 plus 6.94, and then on the outside we need to have a plus D, which is 0.99 plus 0.99. And there's the model that it made. This is what I want you to type in for the equation of the model. And remember that the r squared, the fit, is 0.999. Really good fit. Okay. So that's what I wanted you to say on that last one. All right. That finishes the test.